Hello, namaste, welcome back to my video. If you are seeing the first time of my video, please subscribe. Well, the previous video is to be continued from this video. Now we are in the first chapter, atomic structure, concept 2. In the concept 2, we will talk about the Bohr's theory and EMR. Chapter of our chemistry subject is atomic structure. Concept 1 is subatomic particles. So we will complete that one. So next we are entering into the second concept, that is Bohr's theory. Along with the Bohr's theory, we will deal with also the EMR concept. So there are 7 concepts. We completed one, and in this video we completed another one also. Let's enter into our video. When we see the important IPE questions from the Bohr's theory concept, the questions are arised like this. Postulates of Bohr's model of hydrogen atom, importance of this model and the limitations, differences between emission spectrum and absorption. See it very easy. If you miss the concept subatomic particles, the link is in the below of the description box. So video also I giving you an advice which was my sir told, that is you should maintain a running notes. By this, listening carefully and deciding what to include in notes keeps your mind actively involved with what you hear. Okay. Before entering into the Bohr's theory, I want to explain the importance of the Niels Bohr. Niels Bohr, a Danish physicist, received his PhD from the University of Copenhagen in 1911. He then spent a year with J.J. Thomson and N.S. Rutherford in England. Received the first Atoms for Peace award in 1957. Bohr was awarded the Nobel Prize in Physics in 1952. Also, he was the first to explain quantitatively the general features of hydrogen atom structure and its spectrum. Though the theory is not the modern quantum mechanics, it can still be used to analyze many points in the atomic structure and spectra. Bohr's model for hydrogen atom is based on the following postulates. Here are the postulates of the Bohr's theory. Without wasting time, we can enter into the Bohr's theory. The postulate is electrons revolve around the nucleus in definite circular paths are called orbits. These orbits are named as KLMN shells. These shells are denoted by n, where n equal to 1, 2, 3, 4. So there are also KLMN shells and n equal to 1, 2, 3, 4. When we see the diagram, there is atom diagram. It is hydrogen, not hydrogen atom. It is an atom diagram. So these circular paths are called orbits. Each circular path is denoted by n, where n equal to 1, 2, 3, 4, and another KLMN shells or KLMN shell. That's it. Very simple point. First postulate. Each orbit has definite amount of energy. The orbits are also called as stationary orbits or stationary cells. So very simple point I want to explain on the paper for better understanding. I am trying to draw an atom which have the KLMN shells or 1, 2, 3 shells, and these shells are called as orbits or stationary shells or stationary orbits. Why stationary orbits means each orbit, each circular path have definite amount of energy. So they are also called as stationary orbits. Very simple point. Here also I am explaining in the words. We can easily try to understand for better understand. From the 2 points we got the circular parts called as orbits, energy shells or stationary orbits. The point is, as long as an electron revolves around the nucleus in the stationary orbits, it can neither lose energy nor gain energy. Very interesting point. I am showing you an electron. So the middle one is nucleus. I am showing the circular path of the orbit. Electron which is present in the circular path, when it revolves around the nucleus in stationary orbits, it can neither lose energy nor gain energy. That is a very interesting point. So next move on another point. Fourth point or postulate is related to the third postulate. Each orbit has definite amount of energy. So the energy of each orbit is calculated by using Planck's equation, E equal to NH nu. N means the orbits 1, 2, 3, 4 or KLMN shells. Therefore, the angular momentum of electron, and it is equal to integral multiples of h by 2 pi. There is equation mvr equal to nh by 2 pi. The Bohr also explained the momentum, that is angular momentum of the electron. Here we seeing the angular momentum of the electron, and he given the equation also. Again I am saying mv equal to nh by 2 pi, and the equations m equal to mass of equation terms m equal to mass of the electron, v equal to velocity of electron, r equal to radius of the orbit, h is equal to Planck's constant. Very easy, one easy postulate. Next we are trying to understand energy. Absorbs energy from outside, it jumps from lower energy to higher energy orbital. Interesting thing, The difference between the two orbits is calculated by let E1 equal to first orbit, E2 is equal to second orbit energy, and the equation we got delta E equal to NHU. I tried to explain on the paper. There is an electron on the in the circular orbit. It absorbs some amount of energy from outside. Here I am drawing another circular orbit. So okay. Electron absorbs some amount of energy, it jumps from their state orbit to higher orbit, lower orbit to higher orbit. It postulates, and next one is hydrogen spectrum. Niels Bohr also explained about the hydrogen spectrum. When hydrogen gas is heated or subjected to electric discharge, the electrons in various hydrogen atoms absorb various amounts of energies and jump into various higher energy levels. In higher energy levels, energy is more but stability is less. Completing all points I try to explain on the paper. So next go for another point. Now the stability is less, so electrons return or come back to the lower levels. It happens in a single step or multiple step. Energy is released during this process and it appears as line in the hydrogen spectrum. Electron jumps from any higher level orbit to n equal to 1, 2, 3, 4, 5 Lyman series, Bhohr series, Paschen series, bracket series, Fun series respectively. So UV region, visible region, near IR, mid IR, far IR. And the wave number or wavelength of any line in any series can be calculated by Rydberg's equation. So by this Rydberg's equation we can calculate the wave number or wavelength. Here the Rydberg's equation 1 by lambda equal to r into 1 by n1 square minus n2 square, r equal to 1.099677 into 10 to the power of 7, and this is the diagram of the hydrogen spectrum. It's not clearly understanding you to keep a pic for that. Let me explain on the paper for better understanding. Here I am trying to draw the hydrogen gas. So H, the atoms of the hydrogen gas. So when it is heated or subjected to electric discharge, okay, when the hydrogen gas is heated or subjected to electric discharge, the electrons which are present in the hydrogen gas in various hydrogen atoms absorb various amounts of energies. Okay, it absorbs various amounts of energies and jump into, so let me draw an atom and there are two shells. So and when it absorbs some various amounts of energies, so it jump from lower orbital to higher orbital. Okay, I am trying to explain you. It jumps from lower orbital to higher orbital. Very easy concept. Now in higher energy levels, energy is more but stability is very less. Therefore, electrons return or come back to their lower cells, to their original states. So when this process, it happens in single step or maybe in multiple steps. So when this process is happening, some amount of energy is released during this process and it appears as a line in the hydrogen spectrum. Next time I will write with pen. Sorry for not clear information on the paper. So when electron is released, appears as a line in the hydrogen spectrum. So when electron jumps from any higher level orbit to n equal to 1, 2, 3, 4, 5 shells, we have the shells. So the shells, electron jumps from any higher orbital to n equal to 1 shell, that is called Lyman series, Bhohr series, Paschen series, bracket series, Fun series respectively. So the wave number, okay, the wave number or wavelength of any line in any series can be calculated, in any series can be calculated by Rydberg's equation, and the Rydberg's equation is 1 by lambda r into 1 by n1 square minus n2 square. Very simple. And here r equal to 1.099677 into 10 to the power of 7. So that is called wave number. We can calculate it easily by this Rydberg's equation. Simple theory, that is all about the Bohr's theory. And now success of Bohr's theory. This model has explained the stability of atom, and this model has explained successfully the atomic spectrum of hydrogen atom. Bohr's model has some failures or limitations also. This model couldn't explain fine spectra of atomic spectra. It failed to explain GMAC and Stark effect. So what is GMAC effect? Splitting of atomic spectrum in the magnetic field. that is G-Man effect. Stark effect, splitting of atomic spectrum in the electric field. If it failed to explain the dual nature of electrons, as to Heisenberg's uncertainty principle, failed to explain the chemical bondings of atoms, failed to explain the shapes of the molecules. So these are the limitations of the Bohr's theory, and there are two successes of the Bohr's theory. The model of the hydrogen atom was no doubt an improvement over Rutherford nuclear model. I think you studied about the Rutherford and Dalton's atomic model in earlier classes. So as it could account for both the stability and line spectra of hydrogen atom and hydrogen like ions He plus Li plus 2. Okay, think. Entering into the topic EM or electromagnetic radiation, very interesting topic, and there is a table I see you before. Nature of EMR. James Maxwell was the first to give a comprehensive explanation about the interaction between the charged bodies and the behavior of electrical and magnetic fields on a macroscopic level. He suggested that when the electrically discharged particles move under acceleration, alternating electrical and magnetic fields are produced and transmitted. These fields are transmitted in the form of waves are called electromagnetic waves or electromagnetic radiations. Okay, electromagnetic wave motion is complex in nature. We will consider here only some few properties. Types of electromagnetic radiations which differ from one another in wavelength. These constitute what is called electromagnetic spectrum. Here I am providing the spectrum of electromagnetic radiation, visible spectrum. This is all about the topic. Why I am showing the previous question means I didn't explain the form which is EAZ. So now I am trying to explain. When we see the periodic table, the elements are in the form of this structure AEZ. So here A means it is present in the superscript, that is mass number, protons plus neutrons, and Z is present in the subscript, so that is atomic number, and the middle of A and Z in between there is present in the element. So here I am providing the phosphorus structure. I think that with the pencil it is not better understanding. Well, I am signing off, and today summary of the video is we talk about the Bohr's theory, limitations, drawbacks, success, EMR. That's it today's video. If there is any mistakes, please try to comment on the comment box. I will improve myself, and thank you for watching. Stay tuned, keep watching, and don't forget to subscribe, like and share, and it to be continued in the next video.